Here's the first example in which we're going to solve for an angle. In this case, let's just label the triangle and see what happens. We have the hypotenuse, which is always opposite the right angle. The 5 meters is opposite to the desired angle theta, and then the other side labeled as adjacent is something that we really don't need to have or find. Using the sohcahtoa acronym, we can see that sine is the most appropriate ratio to use since we have the opposite and the hypotenuse. Let's write down sine of theta. Using that fraction, we would have 5/17. In contrast to the previous examples, we are now solving for an angle. So what do? You take the inverse. Let's do that as follows. Notice that I don't really care what 5/17 is as a decimal. I just can do that on my calculator with brackets or with a couple of operations. So don't waste your time making that into a decimal if you don't feel like you want to write that down. And when you evaluate the inverse, you get 17.1 degrees.